Hello students, in this video we are going to study about the methods, techniques and the equipment involved in the construction of metro, mono and maglev trains. So we will see the introduction. The railway system occupies significant place in the realm of the transportation. Comparing it with the other means of the transportation system, this particular mode has a greater advantage as it can carry a large number of passengers and large and heavy loads to the long distance. Railways underwent tremendous changes in the term of shape, speed, mode of running, distance of whatever field human mind can imagine. Among those changes, most important one is considered to be the emergence and the spread of the metro rail system. So the metro rail in India. The rapid transits in India consist of metro, monorail and light rail system. The first rapid transit system in India was in Kolkata Metro, which started in 1984. Elathuvalapin Sridharan, popularly known as the Metro Man, was behind this great effort. The metro rail system in India is popularized and developed due to his amazing effort and hard work. The metro rail lines in India is composed of both standard gauge and broad gauge. Projects like in Delhi Metro used broad gauge for the earliest line, but the new project in India are on standard gauges. As the rolling stock is imported from Europe is on standard gauge. One exception is of Ahmedabad Metro, which has planned to use the broad gauges as there is more space available inside the coaches. Now, construction of metro rail. The essential ingredients of the structure of the metro rail are viaduct, elevated station, tunnel, underground station, workshop cum depot. Now we will see about the elevated viaduct. Broadly elevated viaducts are conceptualized as precast segmental box girder which are epoxy jointed and internally pre-stressed, except in some stretches where the pre-stressed eye girder in the combination with cast in situ RCC deck slab and diaphragm are used. However, at the divergent track location, either cast in situ voided slab structure or girded slab superstructure are used. Launching of segments are carried out using overhead and underslung launching girders. It is worth mentioning here that in case of metro viaduct, the riding quality comes from the continuity of the track. Hence, the most of the metro viaduct comprises of a simply supported span superstructures, where 3/4 span continuous superstructures have been provided for controlling depths. So this is a precasted segmental construction using portal and piers. This is a precast segmental construction using overhead launching girder. Overhead. This is a underslung launching girder. This is a viaduct using U girder. Pier segment that is being raised. Now we will see the precasting, transportation and erection. There are mainly two ways of precasting the segments, that is the long line method and short bench method. The former requires the constructor to replicate the span of a particular construction stage as casting bed, wherein all the segments are cast next to each other by match casting technique. In this technique, the outer shutter is placed on a collapsible platform for easy removal. The inner shuttering is made cantilevering type, which can be inserted into the outer shutter and extracted easily. The bed at bottom is attached to a shaft which can pull the bed on rails after lowering the segment onto the movable bed. In order to further speed up the process, the precasting, the entire reinforcement cage of the box girder segment is prefabricated elsewhere in the yard. lowered into the outer shutter using a crane. Since the reinforcement cage is not structurally strong enough to take the handling forces, it is temporarily strengthened using structural steel sections. This way, a high speed of the production of 1.5 days per segment per casting bed could be achieved. The transportation is restricted to the night time only in order to reduce the traffic problems. The erection of segment at site is facilitated through heavy-duty cranes. In some cases, the low-bedded trailer is placed directly below the launching girder for a pickup. The segments are adequately secured to the trailer bed with the help of chains and steel members to ensure control over possible toppling of the segments during turning of the trailer carrying it. Now, the launching and joining. The launching of the segment is an important activity. There are broadly two ways: one using underslung launching girder and other using overhead launching girder. The former entails lesser height during construction and is comparatively slower. The latter one is faster and better method of launching. It entails hanging of the segments with wire ropes using electrically controlled pulleys mounted over the overhead launching girder. Now this operation comprises of placement of bracket and pier frame on the forward side which supports the girder, then lifting and placing of the respective pier segment over temporary hydraulic screw lock jacks. Next, placement of the girder over the pier segment where the pier frame becomes redundant at the stage and can be taken to the next pier. And the other step is that erecting the segments of the respective 3/4 plus 1/4 of the span. Now the major constituents of the railway track. Once the entire span length is applied with epoxy bonding agent and temporary pre-stressing is applied, the permanent pre-stressing is applied and temporary pre-stress is demobilized. So this is how the pre-stressing is applied and demobilizing is done. At this stage, the girder is ready to move for the next span launching. Now we will have a look at a monorail. Monorails have found the applications in airport transfer and medium capacity metros. To differentiate monorails from other transport modes, the Monorail Society defines monorail as single rail serving as a track for passenger or freight vehicles. In most cases, the rail is elevated, but monorails can also run at a grade, below grade, or in subway tunnels. Vehicles are either suspended from a straddle, a narrow guideway, or suspended way or a straddle way. The monorail vehicles are wider than the guide way that supports them. Now, the structural components of monorail. There are three components: the guideway, the pier supports, and the foundation. The guideway is the most essential and unique aspect of the monorail system. The ideal guideway would be of uniform dimension, which dimensions should be toward practical minimums that provide complete housing of and access to all basic system support hardware, which will be visually attractive and acceptable and be structurally sound and economically realistic. No compromise might be made on the structural capacity and the provision for the support hardware. There are three basic types of pier supports that are T-shaped, inverted J-shaped, and single column support. If the two-way traffic is desired, the T-shaped pier support will economically support one rail at each end of the cross member. The inverted J-shaped pier support is used when only one-way suspended monorail traffic is desired. And the single column support is used for one-way supported monorail traffic. The placement of the support is perhaps the single most element in the structural evaluation of the guideway types. First and most obvious is the pier support that must be kept clear of the intersecting streets not only for vehicle clearance but for sight distance as well. and currently accepted form of foundation system can be made sufficient to meet the loading and peripheral requirements imposed by the system. The most critical loading on the foundations will be movement caused by the lateral wind load on the vehicle with pier support and centrifugal force from the vehicle. Now, what are the purpose and benefits? The Monorail project is seen as a better solution in the areas where roads are unable to be widened due to structures on the sides. It reduces the property loss to residents as well as lowering land acquisition costs. The monorail is eco-friendly and easily accessible, causes less noise, it reduces traffic congestion. The passengers traveling to the suburban locations are benefited due to interconnectivity. Now the advantages, as we have seen the benefits, it requires minimum space. They are wider than the beam, and the monorail systems are commonly elevated, so minimal footprint for the support pillars. They are usually less expensive and having a small footprint. And monorail is by design a grade separated system. They do not interfere with existing transport modes. They are quieter as modern monorails use rubber wheels on the concrete track. Disadvantage: they are not compatible with any other type of rail infrastructures. They do not easily accommodate at grade intersection. In an emergency, the passengers may not be able to immediately exit because an elevated monorail vehicle is high above the ground and not all systems have emergency walkways. The turnouts, especially at high speeds, may be marginally more difficult compared to conventional railway points. The monorail infrastructure and vehicles are often made by separate manufacturers with different manufacture using incompatible designs. Now we will talk about the maglev train. The maglev, that is derived from the magnetic levitation, is a system of transportation that suspends, guides, and propels vehicles, predominantly trains, using the magnetic levitation from a very large number of magnets for lift and propulsion. This method has potential to be faster, quieter, and smoother than wheeled mass transit system. This is a maglev train. The power needed for the levitation is usually not a particularly large percentage of overall consumption. The most of the power is needed to overcome air drag. Now the principle. It is a system in which the vehicle runs levitated from guideway by using electromagnetic forces between the superconducting magnets on board the vehicle and coils on the ground. The principle of magnetic levitation. The eight-figured levitation coils are installed on the side walls of the guideway. When the onboard superconducting magnets pass at a high speed, about several centimeters below the center of these coils, an electric current is induced within the coils, which then act as the electromagnets temporarily. So this is the eight shape, the red and blue one, where the principle of magnetic levitation takes place. As a result, there are forces which push the superconducting magnet upwards and ones which pull them upwards simultaneously, thereby levitating the maglev vehicle. Now, other principle is of lateral guidance. The levitation coils facing each other are connected under the guideway, constituting a loop, and then the running maglev vehicle, that is superconducting magnet, displaces laterally an electric current induced in the loop, resulting the repulsive force. Thus, a running car is always located at the center of the guideway. Principle of propulsion. The repulsive force and the attractive force induced between the magnets are used to propel the vehicle. The propulsion coils located on the side walls on the both sides are energized by three-phase alternating current from the substation, creating a magnetic field in the guideway. So this is how it is been in center. The maglev train acts as a superconducting magnet. The onboard superconducting magnets are attracted and pushed by the shifting field. So if we have ever played with the magnets, you know that the opposite pole attract and the like poles repel, and this is the basic principle of electromagnetic propulsion. Now the working. The maglevs incorporate a basic fact about magnetic forces like magnetic poles repel each other and opposite attracts. The magnetic propulsion and the levitation may involve use of superconducting materials, electromagnets, diamagnets, and rare earth magnets. Now, the EMS uses the attractive force between the magnets present on the train sides and underside, and also on the guideway. The attraction from the magnets present on the underside of the vehicle that wrap around the iron rails of the guideway keep the train about 1.3 centimeter above the guideway. The EDS, that is the electrodynamic suspension, are similar to EMS, where the magnets are used to repel the train from the guideway. The magnets are supercooled and superconducted and have the ability to conduct the electricity for shorter time after the power has been cut. Also, the like EMS, the charge of the magnetized coils of the guideway in EDS repels the charge of the magnets. The EDS trains are slow to lift off, so they have wheels that must be deployed below the approximately 100 kilometers per hour. But once levitated, the train is moved forward by propulsion. Now the benefits. They are less expensive to operate and maintain because the absence of rolling friction means that the parts do not wear out quickly. Fewer materials are consumed by the train's operation. And the design of the maglev cars makes the derailment high unlikely, and the rail cars can be built wider than the conventional rail cars. It produces little to no air pollution during the operation as no fuel is being burned, and it provides a very smooth ride for the passengers. Finally, the maglev system operates on higher ascending grades than the traditional railroads, reducing the need to excavate tunnels or level the landscape to accommodate the tracks. So we have seen the metro rail, monorail, and the maglev trains. Thank you.